specifically interesting that you need to learn about me tonight, apart from one fact that you can trust what I say about Fabric. I've been working with Fabric for many years now. That would be almost 3 years at this point. I'm certified in Fabric certifications. I have a lot of hands-on experience. I professionally work on implementing Fabric solutions. And what I will be showing you, it will be a hands-on, real-life, live situation. So no video recorded, nothing like that. No pictures apart from the slide deck, which is for the beginning only. So and that's about it. What we will be looking at today is three things. First, and it's interesting because essentially I will be talking about the Fabric IQ, but I start from the AI agents. Well, they are related. And the reason why they are related, because Fabric IQ purpose is exactly that, is to make sure that AI agents, which is our new and exciting technology in all the industries, the AI agents, we want to use them to access the data. And we may have issue with that. So we will learn what Fabric IQ does about it. Second, that I want to show you that there is a part of the Fabric IQ which is called ontology, and how it works, and what it does for achieving the goal of making sure that AI agents actually can understand the data. And the next goal for tonight is we will have a live session with the Fabric hands-on, where we will learn how it's actually done, how it works, and we will see that in action. Now, one disclaimer before I continue further is this is not a finalized, polished presentation by all means. This is a work in progress. While ontology had been introduced for over half a year ago already, since last year before Ignite conference, it's still in the preview. It's not the general availability item in Fabric, and it doesn't work without glitches smoothly as promised. So expect some roughness during my especially live part of the presentation. Expect things that are not expected. That's a quick disclaimer, but that's exactly why we will be having the Q&A at the end. Now, going forward, what is that problem that we may experience with the AI agents? Well, when we ask them questions about our data, the data may look in a way that even humans cannot understand it. The reason is because it's a technical implementation. What it means is that it was created by technical people who may not specifically be interested in making sure that people who are not technical can really understand that. And you can see from this point of view, I have that picture that column names, data, this is all a blur, right? So just imagine that because the AI agents, they use models that were modeled from the human brain, they will have exactly the same first impression, right? So if we ask them, hey, tell us what exactly is something like we were talking before that about the hospitals and things, and I see, for example, we have a table here that doesn't make sense in terms of the column names. So trying to answer questions may not necessarily give us the correct answers. Likely we'll have the opposite. And result, it will not be a satisfying conversation. Believe me, that the reason that you wanted to use the agent, you will not achieve your goals in such scenario. So we need to make sure that the technology actually works to our benefits and we're not just wasting our time here. So does this problem then understood? Now, what is Fabric IQ? Fabric IQ is a technology that exists in Microsoft Fabric, a new generation of a unified analytics platform. And it consists of multiple items. Like the most important item that is part of the Fabric IQ is called ontology. And ontology lives on top of one lake. What is one lake in Fabric? One lake in Fabric is the unified storage where all the data exists. So why ontology lives on top of one lake is because it represents data to the Fabric agents that consume ontology. And the principal difference of the ontology being the new item in Fabric is that it is a new semantic intelligence layer. Whoever is familiar with Fabric and reporting specifically on Power BI, you already know that there is a semantic model that is a part of the modern reporting and analytics. And the purpose of the semantic model, even though it's called semantic, but it brings a limited semantical context into the data because it still operates against the raw data using exactly the same data structure that is original. And it may bring additional things on top, like measures and stuff, but it doesn't answer all the semantic context questions from the AI standpoint. That's why ontology. So people at Microsoft who's been working on this technology, they decided that it's time that we optimize how data can be accessed from the Fabric by the AI agents that we want to keep using. And if we look at it, we actually can see that ontology is not a new thing. It's a well-known item. It's a well-known technology. It's been around for a very long time. And its sole purpose for all the times was to model the data in a way that makes sense for business. Like why business? Because business is something that people work in. Business is something that is created by people and used by people for people. So that's why the data modeling is should target that specific way of looking at the data, not the other way around. We don't need the technology that only works for itself. We actually need the technology that works for people that can use it to achieve their goals, right? So now ontology is a structured knowledge graph that represents a specific business model. And you might notice the pictures here, but they're for illustrations only in this context. So wait until the live demo to actually see how they operate and how they work. Now, ontology consists of entities. Entities specifically represent the business objects that should make sense. For example, on this picture, what we're looking at three different entities: sale event and product and the store. And if we're running a business, or if we're even just the customers of this business, we absolutely understand what it means. We go to the store to buy some products and we always look for the sale to make sure that we get the best price. So that's exactly what happens. Now, how do those entities connect to each other? Through the relationships. And it's similar to how it's done in the relational databases, but it's not the same, because even though there is real data behind ontology, but it's not necessarily modeled precisely the same way as the data structured. And that's the difference between the ontology and the semantic, traditional semantic model. Now you see here we have the relationships that, for example, a store runs sales event and the products are sold during that sales event, and that's how we understand what's happening here. Additionally, what happens here is that for each entity, we can define two additional things. Number one, we can define the property set, which explains what that entity is and how we can understand one instance of that entity from another instance. And also what we can define the business rules. And business rules are similar to the business logic, except that at this point they make sense. For example, we say, look, when we define a property in the entity that is supposed to tell us about the revenue during the sales events, we call it this way. We don't care to keep the name that was originally in the data structure, and so on and so forth. So this humanized contexts are automatically brought into our scope in this ontology by designing it this way. More importantly, that ontology is not a theoretical layer. It is bound, it's connected to the actual data that lives on one lake. And as opposed to traditional semantic model, ontology actually can combine data of two different types at this time. I believe that the number of data types, it will grow over time. Right now, we're talking about just the two. Number one is we're talking about the static properties that come with as the entity characteristics. For example, a color of a product or a name of a product, a number of a store. They don't change or rarely change. But in addition, we also can have the time series or real-time information data associated with each entity. And I'll show you that this is not a simple task to achieve that, because these are completely physically separate storages and they operate with different rules and using different interfaces. So the way how ontology merges them together, it's almost magic. And there we go to the next now, because the whole point of us having this ontology was not to help ourselves to understand the data structure. It may be a fun exercise, but really, if we already have a report, we don't really need that for human consumption. Other humans can help us with that. But what we wanted to achieve is we want to make sure that the machines, the AI agents, the models, they understand the data correctly, right? Now, when ontology creates the model that has full semantic context, and machines are happy because they can work with that, right? So now we have the situation when we resolved the frustration from having the wrong answers to our questions, because now we make sure that ontology helps us to get the correct answer. So if we just recap that, without Fabric IQ, when agents work with the raw data, they may be missing the full picture and they may answer very wrongly to our questions. Now, with the ontology, because we designed the ontology model in a way that it includes the proper relationships and includes the properly named semantical properties that also include the business context in it, then we expect that to change and to almost like we're talking to a human with the same knowledge as we are. On top of that, because obviously we will have the benefits of using the natural language instead of operating with the machine-specific language of like SQL or GraphQL or KQL, any other query language that might exist. We don't want to learn that. We just want to use our natural language that we're all pretty familiar with and to get answers to ask the questions and to get the proper answers. And now the same ontology, it has multiple benefits. Specifically, it's one data source that can be reused multiple times. On this slide, I say that it also works with the operations agent, which is also part of the Fabric infrastructure, but we won't be looking at it. But I will show you something else that is not on that slide. It's a little bit of surprise. We'll leave it for later during the live. So I'm just giving you a point to get excited. Now let's take a look at what is end-to-end architecture. This picture is what's called normally a lineage diagram. So what you see here, it represents how the data and items in the fabric will be physically connected in our environment when we start working live with fabric. So we have on the very left side, we have the data sources, and we have two of them. We have the lakehouse that is here represented by the name ontology data LH. And we also have the event house, and the event house is a special database in Fabric. It's called this way, event house, but essentially it's a KQL database that is optimized for time series information. What time series means is that it's the same value or property that is measured every single moment in time with the certain frequency, and its value that was captured during that measure, it's recorded. So that's why it's a time series, because the same value, its fluctuations, its deviations, its changes, they're being recorded with the timestamp. So that's what we call usually real-time data. And what happens here, I already explained. Now, from this data, what we will do, we will create the sales ontology. This is the object that will consume all this information. And this is a screenshot from the actual fabric. So things like SQL analytics endpoint and the KQL database itself we likely won't be using today, but they're presented on the diagram just for your information. And once we have the sales ontology ready and working, we will connect it as a data source to two different places. We will use the sales agent that we will communicate and chat with. And we also will have the map ontology, the map item that we will be using to display the spatial information that may or may not exist in our data set on the actual map. And that's that surprise that for some reason my bullet points are in the weird order, but that's okay. So the result of all this, that we build one ontology and use it with multiple experience and reuse it multiple times. Now, that's all for theory for today. We will touch a little bit later during the live demo, but also we can talk about things more during the Q&A if you wanted to. Don't forget to record your questions into the chat. But now it's the demo time. So as I said, all these objects that this constitutes our demo environment, we will switch over to Fabric and we will start looking in them. And let me tell you a little bit about data first. So what's the data set? It's exactly the part of it is exactly the same as the data set that if you go to Microsoft Learn to learn about ontology, they will let you use the specially presented data set that represents a retail business of selling the ice cream in stores. So it's pretty simple, and it's not very sophisticated. Now, because this is a work in progress, this is not the very first time that I'm showing that specific demo, but it's a version 2. It's the evolved demo. So I added additional data into it. Specifically, I added the ice cream truck because I think it's fun. It's not just the store, but also we have a moving object. And in Fabric, we will be using the items of Lakehouse and Event House and Ontology and Sales Agent, Data Agent, and a map. And the demo itself will consist of 3 different parts. Like first part, I will show you how to work with the ontology and what it looks like and what features it itself present. And then we will switch over to working with the sales agent. And we will interrogate that poor machine with our sophisticated questions, and we'll try to break it and see what it can do, what it can do. And we will experiment a little bit with the instructions that we will give the agent so it can work better with this data. And the bonus part, which didn't exist before, we will use the map. It didn't exist before because this was a relatively new feature. I only discovered that about a month ago. And we will look at the map and how map can display the live data. And that's all for the theory at this point, and I'm ready to switch to the live Fabric environment. Well, that may be a good time if anyone wants to ask a very quick question before. If not, then I'll give you everyone just about a few seconds if you want to. If not, then we'll just proceed. Sounds good. So we are in Fabric at
Sorry,
this point.
Alex, I think we have a question in the chat.
Okay. I don't. Well, should I? I can't. If you can read it,
It's okay.
maybe.
Sure, sure. It says it's by Daniel. He says how influential are semantic models in derived ontologies?
Well, semantic models, they're an intermediary between the raw data and the ontology. So you can create an ontology from the semantic model. So obviously, if you extend the raw data in your semantic model and you use things that are not in the raw data, but only in semantic model, that it will be influential. But it's a matter of how you design your data sources, essentially. Did I answer?
Yeah, I think
Okay.
you're good. Yeah, sure.
Okay. Okay, so what we see on the screen now is our Fabric environment, and I explained to you before that we have different objects here. So we have the data source, and I need to switch to a little bit. Just give me 1 sec. All right. So we have these objects right here, and I must give you a preliminary information that to use the AI agent like this one, you have to use the commercial capacity. Like you see, I have the trials activated here, the banner. It's not true because for this workspace specifically, we're using the commercial capacity right here. It's F4. And without the commercial capacity, the agents won't work. Trial capacity does not cover AI capabilities of Fabric. So we have two data sources, right? We have ontology data and we have telemetry data, event house. Let's look at our lakehouse first, and we'll see what data we're working with.
Hi,
Hello,
I am good.
someone joined us.
Yeah.
Right, so we're in the middle of
Hold on, I
presentation.
go.
Please keep your microphone muted at this point because we're not still in the open question period. Thank you. All right, so what we have here, we have actual data, right? So we have tables, we have products, we have stores, we have sales, we have a freezer table, and we have a truck table. Nothing special. Not too much data. We only have three types of ice cream. Sorry to disappoint everyone. If you like more flavors, you need to go to different stores. This one just can't do this. So next, what we have is we have our event house, which is a KQL database with the telemetry data. And that looks a little bit less friendly than the lakehouse because lakehouse is just your normal structured tabular data. However, here what we will see is a slightly different format. If you're not familiar, don't be alarmed about it. We won't be working with this specific thing. But just so you understand, for example, for freezer telemetry table, we for each freezer, right, we record with the timestamp. We record from sensors their temperature, their humidity, whether their door open or closed at the time of recording, and things like that. And we have some data there that we will be looking at. Similarly, with the truck telemetry, we also record additional information about the trucks, specifically how they move, right? So we're interested where they are located physically in the world, what kind of speed they're currently, what direction they're headed, and what's their status. That's what we're looking at. Uh, Now, what else we have in our environment that is worth looking at is our sales agent and, of course, ontology. We will leave ontology to the end because it takes more time to go through it, but we'll show you the agent, how it looks, and that it's connected to our ontology. We're not going to talk to it right now. It will be our next step. Now, at this point, let's do one quick exercise. What I want to do before we go to our ontology and explore it, I want to show you how it's created. It's relatively straightforward. I have absolutely empty workspace here, so I click the new item, and I should be able to find the ontology here in this list, right? I have it in my recent, obviously. But if you don't see it, you just use this filter and you will find it from the list like this. So I will select this. I will say that I want my new ontology. And it will be created for me. Now, because this is a live environment and we only have the F4 capacity available for us today for this demo, just keep in mind that some things they may take a little bit of time, but we just need to go through anyways because it's part of our experience, including understanding how the fabric works and what kind of speed we should be expecting from different situations. Creating ontology is not a quick process. The reason for that is I'll show you what's inside. So if we look at this previously created ontology, you see it consists of multiple components behind the scene, right? And you see how those components are being created right now for us, and they already now created. Now it's very empty. There's nothing in it at this point. But we know that it consists of entities, so that's what we do. We create the very first entity, and let's say that it's going to be a store. Because we will have the store entity. And if we were just working with the ontology as it is, being a data model, we would just go ahead and start adding properties, but we have a shortcut. And the shortcut allows us to add the properties from data. So obviously what we can do is we can select the data, right? Now I didn't show you. Let me start over. So when we select the data, only two data sources currently are available for data binding. It's either a lake house or an event house. Now someone may say, look, but in Fabric we have other data sources, right? We might have a database, we might have a warehouse. Like, how is it? Why are we limited? I cannot tell you exactly what's behind the technological limitation that only allows us to pick these two, but there is a workaround. Okay? So if you have other data sources, you need to use a technology, a Fabric technology that's called a shortcut. For example, inside the lakehouse, you can bring a shortcut from a table that belongs to a warehouse or a database, and it will be available then. Okay. Now I have many different things here, but I know exactly my source that I will be using, so that's why I confidently pick it, right? And now we need to, because it's a single entity, so we always want to have a single table source that we can map to it. It doesn't mean that we can only use a single table source, but we start from one of them. And in this case, in my lakehouse, I have the table that's called dim store. That's the one that I will pick. And see the magic that will happen right now. That's what I'm showing you. That's how we're creating, right? So these columns will appear in the list automatically mapped. So these are on the left side, these are the table columns in the lakehouse. But on the right side, we map them to the property name. So we can keep that mapping, right? Or we can change it. So if I just start typing, I can make a property name look differently. I don't need to at this point because this is just the demo. And that one important thing is that we have a warning. Entity type key missing. What does it mean? That means that we need to distinguish between each instance of this entity. And instance means an individual physical thing and business, right? So for example, if you have many stores, then entity is a store, but each individual store is an instance of that entity. And I want to be able to identify it. In my data model, I have the store ID. That's the one that I will be using. So I will need to click on the button define entity type key, which is very obscure, grayed out for some reason, right? But it's work in progress. And I will select the store ID as my key property. That's important because without assigning the key property, there's no way to introduce the relationship. And then I will save it. Now, that's done. Let me go back to the ontology. I click cancel here. I'll go to the home tab and I will add another entity. And this time it will be a freezer. Of course, you now know that we need to add the properties to the freezer, right? So, and I can do this multiple ways. For example, I can just say view entity type details right here. and use exactly the same path. Or if I went back here and chose this, I can just simply say bind data from the freezer. It will bring us to exactly the same dialog, just a couple of different paths. So I will use exactly the same lakehouse, and I will choose just a different table for that. In this case, it will be a freezer table. And we will wait for the magic to happen. And we know that that we have to define the property, the key property, which will be the freezer ID, right? And I will save it. So the next is what we want to do is we want to add the relationship. And we know that relationship that we want to add, we must know our business, of course. This is all business context, right? I don't need to know the data model. I don't care for the data model that is behind my ontology. But I know that stores, they operate freezers, right? That's what I will do. I will say that operate is my relationship, and where it originates at the store level. But what is the target? Well, in this case, we have just one other entity. Of course, it's easy to pick because there's only one. But if we had many, we would still know that it works like this, right? So we can always click on it, and we have to click on it, and we need to configure it, right? Because we need to actually assign the mapping table, and the mapping table is always the table that defines the connection between one entity and another. In this case, the mapping table defines store ID for us and nothing else, right? So what's the problem? We cannot find the freezer ID. Well, the problem is that the mapping table is wrong because it doesn't have both of connections, both of ID. That's why we need to choose a different one. Now we have the store ID in the freezer table, and we have the freezer ID automatically identified. At this point, this relationship becomes functional. So this is how we create, in general, the ontology. At this point, I'll just close that, and I will switch to my actual ontology that was prepared for you already for this demo. But you already know how I created it. Now let's see what I can do in this ontology for this ontology. I already described to you that I have all the entities right here that I defined them. And a couple of things that I want to show you first. Obviously, we can click here and we can understand that we have the data bound to our properties. And we have relationships, but look, we have more than one, right? So we need to look at those relationships. We want to look at those relationships. So if we pick one, we see that this relationship is between the store and the truck. Now, and it's called dispatches. And what happens here is that in the truck table, we have columns for the home store ID. That's where the truck belongs to. And also we have the truck ID that identifies the truck. So that's one thing, relationships. Second thing is a little bit more interesting because what we didn't see in the previous example is that apparently if we just look at the entity type, that's relationship, no. So if we look at the entity, we see that in this particular scenario for the freezer, we have more than one data source associated with the properties. You can see this in the data source. We have two different data sources. We have the lakehouse, the one that we already looked at, but also we have the event house KQL database here that we bind to the properties that don't change. That's an interesting twist. We didn't have it before. Now I can show you that if I choose a slightly different entity here, the truck, it will have the similar situation. This is exactly the magic that ontology does that the semantic model cannot. It doesn't understand different types of data storages and it cannot connect them together. All right. So now let's take one of those entities here and look at them. And you see this as a sales event and the product and the store, right? Let me just actually take the different one. Let me take the store entity that has the most, yeah, doesn't show well here on this one. So when this happens, what we want to do is we want to use the special new tab. It's called Overview. Before we switch on it, I mentioned multiple times instances, and you see there is a tab for that. So what it allows us to do is just to preview the data. For example, for the stores, I can see that I have 3 different records. Right now, I have a store in Berlin, in Paris, and Amsterdam, in different countries, and they all have the names. They all have the coordinates. It's a spatial, geospatial information. That's important. Now let's click on the overview. And this is the heart of the ontology at this point. So overview is a dashboard. It's a collection of tiles. So each individual tile here, it's pre-created based on what exists in the store. There's a list of tiles, so technically we can add additional tiles right here ourselves, and we will look at a different entity and we will see how they work. One particular tile that still doesn't work, it's called the map. It, at this point, you see it's at the bottom. It doesn't work. There's no documentation for that. I imagine it will be working sometime in the near future because it's already available to be added. But when we create the overview, it's not, I added it manually. So it's not added automatically, meaning that this still not working well enough. Now, one important thing that we want to understand here is this. How ontology organized data is through the graph. And we mentioned before that ontology, it's a structured graph. What it means is that it's really a graph. So it uses the GraphQL language. It's an engine. It's a compute engine behind this whole functionality. That's the connector, because the graph is the way to connect different objects and different data sets into a single cohesive picture that can be queried by data agents. Without graph, that's the magic, that's the glue. Without the graph, it's not going to be working. So graph is the one thing behind the scene that does this all. So just to show you what it actually means, we'll just play a little bit with this graph. And what we will do, we'll click the run query. This is a query builder. I selected everything. And this is the result, right? That's what was returned from my live data. So now we see that for that initial graph picture that we saw from in our ontology overview, now we have a collection of entities that are connected to each other, right? And if I pick one dot, which is in graph called a node, I can see what happens here. So we know that this specific entity is a store in Paris, and it has 2 freezers, right? 01 and 02, and it's located at a specific, it dispatches a single truck that currently is located, the pink one, this guy, it's a truck, right? So it's located at a specific place. We see the coordinate here, 1. And that is actually an interesting thing because I didn't notice that before only one of the coordinates shows up in here, even though there are two of them. There's a longitude and latitude, obviously, right? We're living the uh, more dimensional world. And obviously we have here the products that we sell. So that's what the graph is. And we're not specifically here to learn how to work with the graph, but it's relatively easy. We can add filter. For example, we can select a specific store just by doing this. And we can say that the store city is Paris. And if we just apply that filter and run the query, then we should be able to see that that's the only data set that we're now will be looking at because that's the Paris, the filter that we applied. Think of it as a where clause. That's the thing. All right. So the last demo for entities in the before we switch over to our agent, we will look at the freezer overview. The reason why we want to look at the freezer overview is because if you remember, we have different types of data present, and that's what we want to see. We have the time series tile here that shows us, for example, that the temperature in a specific freezer, it was changing over time like this, and the door was opening and closing. So it's alive, right? So that's what happens with the freezers. Other things are still static because they come from specifically a lake house, so they don't change their static properties. But that's what we can see. Right. Okay. Now it's time for playing with this guy. So the very first thing that I should have done, which I already did, I should add data. And if I add data, I can add the data source. And if I use the data source, I have access to all different types of the data. I have the KQL database, Lakehouse, mirror database. I can use semantic models as the data source for data agent, and Fabric is very multilingual. It speaks all kinds of languages that Fabric understands, but we will only work with the sales ontology. So that's one thing. Now, to start our experiment clean, right? First one, what I want to do is I want to remove all the context information from here, and I want to remove instructions, right? Now, what I want to do next for the instructions is I want to start from the very simple instruction. The one that means nothing to anyone, really, but I just want to make sure that we understand how it's done. And this is a really simple instruction. It says, hey, support group by in GraphQL language. I don't know why. Don't ask me. This is the simplest instruction that I can come up with that may make any sense, right? And at this point, let's just start because we already know that we have all this data, so we don't really need to beat around the bushes. We just go ahead and we say what is the most profitable product in the stores in our business. I could have said in our business, it's basically the same, but let's see what we come up with at this point. We will look at what's going on behind the scene, but you see that this guy generated the answer for us, right? It says, hey, that's your single ice cream that everybody loves. It's a classic vanilla pint, right? And what we also notice from here is that apparently this is all a JQL. That's what I explained to you before. So the graph in ontology, that what holds together all different types of data, and that's what creates the interface between different types of data and the agent. So agent creates a GQL or GraphQL query that is specifically looking like this. Like, how does it know that, well, the model was trained, right? But we get our answer. So let's get a little bit more sophisticated. Let's say, for example, hey, which region in our business is the most profitable? Well, let's extend and the least, right? So we want to see our range. Now, see, the trick is that um, if we remember that we don't have such a thing in our model that tells us how the profit is explained and what the region is, right? Because we don't have that information. We have the city. That's it, right? But somehow it was able to figure that out. Let's just take a quick look, right? So it takes the sales event and uses the region property in the store. Apparently, we have such property, right? And then it understands that profitability actually means the revenue, right? And then we just group it, and it says these are all the regions that we have, and that's the range. So the Netherlands, probably they prefer different type of products, not necessarily the ice cream. I remember that they have a signature sandwich with the herring in Amsterdam. That's what I would personally prefer over the ice cream. That's probably the problem with the business model. But hey, we're dealing with what we have. But now what I'm specifically curious about is the safety of our operations in the business, because I know that we have freezers, and I know that ice cream, it's supposed to be, stored in very cold condition, right? So I want to ask this, which stores um, had safety issues with in the operations, right? So this is really a sophisticated question, because, like, what is the safety issue? How do we define that, right? What is the operations, right? But let's see what's going on in here. Let's just wait a little bit and just double check. So see how it interpreted, because and the reason there's a simple reason here why. Like, we can find all our equations right here. So we're looking at the stores, and we have a relationship operates. So it's really easy to associate the operations with the operate. So what does store operate? It operates the freezers. But what is the safety? Well, we have a property that is literally called mean safe temperature in Celsius, right? So this is, again, interpretation was really easy. But the trouble now here is that we're asking that, hey, we have a threshold, but how do we know that that threshold was reached or not? The reason how we can, so the way how we can achieve it, we need to look at the different properties. We need to look at the time series property and look through all of them for each store and find that we had at least this recorded temperatures in there. let me bring up the stakes a little bit. I wanted to break it, so that's my honest goal. I just want to see at which point the agent won't be able to answer what I want to know. Like, for example, I want to ask, hey, which stores had the door, freezer door, the freezer door open freezer door open most of all, most frequently. That's probably better. Because I want to see that if there is the concern when the people just keep the door open, for example, or something else, I cannot break it. That's weird. The ontology works very well today. Seriously. When I was testing it before, it shows clearly right here. That's what is. Okay, let me bring up the stakes a little bit more. I want to see that. Each truck. Oh. Which store has trucks that drive with the faster speed on average? No, I cannot break it. I'm sorry, guys. I'm telling you, there's nothing in the instruction here that gives it a hint at all. Like seriously. But it answers all my questions perfectly. It brings together context both from the static and it crosses the bridge between the time series and whatnot. But I still have one card up my sleeve here that I can use. I can bring in the time category, right? Okay. Let me ask this. In which store trucks stopped most frequently yesterday? This is a really complicated question because if I was in the data agent shoes, I would need to understand that, look, how do I get the stop? Oh, finally. Okay, nice. All right, so I was unable. Breaking point. Got it. Okay, so it made some errors here, right? Because let's see what's going on in here. So first, we were looking at the store. That's fine. We're starting from the store, but we know that the store dispatches the truck, so we get that connection from the relation. That's fine. Now, what else? We get all the properties, right? One property, status, right? And we'll also read the time series selector. That's part of the GQL. So we're looking at specific metrics and we're looking at the speed and we're aggregating the speed by count. File to execute step. No data found after query execution, right? So field stopped count. Do we have such a field? Nope. Well, we aggregate the speed as a count into the stop count. No, it doesn't work this way. Like I'll show you. Let's go back here. We have it open. If we look at the track telemetry, right? So what we have here is we have the status, right? And look at the status. So stopped or slow. That's what it should have been using, but it has no idea that the status means anything because it doesn't know. So technically, when the status is stopped, that's when the track stopped. But we shouldn't be analyzing the speed for it because the speed is recorded most likely when the track is moving. However, here it was stopped, but the speed was 20 kilometers per hour, which is weird. But I know, right? Because this was generated. I generated that data. It's not the real data. It's hard to actually simulate data very precisely. So that's fine, but how can we fix it? Okay, how can we fix it? Well, let's try to give it an instruction, and we will just add that instruction here to determine if the truck stop or moving, read from the time series property status of the truck entity. Let's see if that helps. Now we have that. So that's an instruction. Let's ask again. So we'll just go here. I'll just say, try again. It's not that obvious here when we apply the instruction. We just assume that they're applied immediately. We don't really know in or yes or no. But say of truck stops based, see, it picked it up. No, what? Not again. Order by stop. Oh, it doesn't know. It's looking for the stopped. There is no such property, right? Because we already know that there wasn't such. We want to say here that stopped or slow represents a stopped truck value of the status. That's what we want to clarify. Stopped or slow. Good. Try again. Still not. Okay. Well, we're approaching our timeline, but you get the idea. So basically, I played with the situation many times, and I know for sure that it takes a little bit off because I may have misspelled that value and it couldn't find it, but it doesn't show us. It doesn't show us the query that it used, but let's try a slightly different one. That specific period that says like, let's remove yesterday, and we'll modify it. In which store truck stopped most frequently. No. In which stores a stopped truck status was recorded most times? Okay, let's see if we can cross this barrier. So the reason of this experiment is I'm just showing you that when we're dealing with the agent, and we need to be very careful with the agent instructions. The reason being is that while ontology does provide, still no, but at least we could see at this point that what it's trying to do, it's using that specific value. It might be a wrong value. That could be the reason, right? Because I might have just misspelled that. Stopped. Yeah, it's casing is all wrong. So that's one of the reasons. Last attempt. Let's just correct that and see if it helps. I'm just curious if it's really the reason of this behavior. But as I said before, this is the experiment. And that's exactly what we're doing here. We're just playing around on this playground. We're learning what happens here. So basically, when you have a data model and you have a beautiful ontology that you bound to your data, and you think that you may have described your business just amazingly well, then comes the time when the agent still doesn't understand what you want from it. This is when you use your human ability to formulate the conditions. No data was found regarding which store recorded or most instances of drive with the stopped or slow status. There are no such we know there is, right? Something here. Yes, the Ponker has. Go ahead. Hey.
Yeah, Alex. Yeah, I got a question. So, if I understood correctly, so first is your model, then you build ontology, and then by using ontology, so the next step is like building agent by using the ontology. Is that correctly understood, or?
Yes. That's
Okay.
exactly the chain of our objects that will create that pipe of getting agent to answer the questions about the data. So the agent has access to the graph in the ontology. Through that graph, it gets access to the diverse data set that we have behind the ontology, and that's where it gets the data. All right.
Okay. Thanks for this. This is very helpful. I may have, if you allow me, I have one more question. Which is, say, for example, you don't have ontology, but you still can build the agent top of your model, like
Yes.
data model. So when actually you choose to use the ontology? That's my question.
Right. Well, you joined later in our meeting, so we had a bit of the presentation really before, and we discussed that raw data not necessarily the most efficient way of talking with or about, right? Because it may be very crude and it may have absolutely zero human understandable context about the column names and what's inside it and formatting whatnot. And that's exactly what will break your AI model, and it will not allow it to answer. But if we map the data to the ontology, which will create a completely different human understandable context that where we define our entities exactly as they sound in English language or any other human language, and we give them properties that make sense. For example, you saw, all of you saw that revenue USD allows this model to easily discover that profitability is essentially that, right? And similar things. So we bring in the context. So we bind, and the secondary part is that we bind to the ontology different types of data, which cannot be done in the raw data. Guys, well, let's give me a couple of.
Thank you so much, Alex.
Yeah,
Thank you.
no problem. We'll have the QA just in a minute. What I want to show you one more thing here is the map. It's very exciting. Also a little bit cool. So let's see what we have here. So this is a map component in Fabric. And you see what I mapped here is as a data source. I'll show you. Just the ontology. That's it. That's all that we have. But I specifically selected stores and trucks here to be shown on here, right? And one thing that I want to show you is this. If I just zoom in, you will see that we have a store right here, right? It's our Amsterdam Lakeshore store. We know it's the least popular because everybody around here prefers red herring versus ice cream. So what? Like, and we have our truck, right? And let's just notice the timestamp here. So it was May 13th, 02:49. Okay. And it was moving with the speed of 32 kilometers per hour at the time when we display. So what map does, map only shows here the very latest record available. Now, what I'm going to do here is I'm going to switch back to my KQL database, and I have here a cheating instrument, right, which specifically simulates, you see I have on the comment here, right? So I want the track to move. So basically I just insert the new record. And I insert it. And now I go here and I click, hey, Amsterdam. Oh, it's reading, right? So see, it already moved. It was 02, if you remember timestamp. Now it's 23, right? Because I was testing yesterday evening, so it was almost 24 hours ago. I can do the same. I can insert another record again and show you all different cities, but that's the cool part of the map. So I don't know how many of you have seen that presentation that Microsoft showed during multiple events recently with the air company, where they had the airport picture and flights are flying in real time on the map, right? Anyone? Show me your hands if you don't mind, if you've seen it. If not, then we assume not. But if I turn on the automatic refresh here on this truck, and I start running real data updates there, well, that are currently they're simulated, but they're not supposed to, but you understand that this truck will be moving here like this. So that's what it will be doing. Okay, so that's all the demo that I wanted to give you today. And hope you learned something new. I'm not sure that if you liked it or not, whatever that was new, but that's not the point. The point is that you learn it, that you've seen it, that you will leave home with new things. And that's exactly what I want to finish with right now, that our key takeaways, like, so Fabric IQ is a semantic intelligence layer. It doesn't replace your data. It lives on top of your data, and it creates a way of describing data that is much easier human understanding, which automatically enables the AI model to operate with data on the same level as humans. So Without the context, AI agents are not reliable. Now, we've seen only one sample that I was able to break it. It couldn't connect for some reason the truck stopping state to the data that existed. It was there, so I may spend a little bit more time on it. I'm telling you, that was live experiment. I've never asked that question before. I asked different questions where I also broke the model with this disconnect, but that was the new one, and I wasn't able to solve it at this point. So I may still play a little bit with it, and maybe I report back. Look up on the LinkedIn. I will post if I figure out what was wrong. I'll post on LinkedIn. And then finally, the combination of the data agent and ontology is the way how today Microsoft Fabric suggests that we create the trustworthy, context-aware, AI-enabled data interface. And that's all I have to say for today. And now let's switch to the Q&A. Fernandez have a hand? No?
Hi, Alex, or
Yeah.
Alexander, sorry. Thank you. Thank you very much for this. This is a really great walkthrough, especially with Fabric IQ. I've heard about it, but I haven't seen it in action. So very nice to see this as well. So as I had mentioned, maybe before before you started, I work in a hospital or healthcare setting. And one of the things that we contemplate when we introduce a new product, whether it's a data product like a Power BI report or dashboard or something like that content, or even an agent, in the future when we turn on Copilot and start to build some of this out. The question I have for you is, and I appreciate the fact that you tried to break the agent with the questions that you were asking. My question is, how prescriptive do you feel you need to be with some of the underlying semantic model that you've already built from your data model, and then also this ontology layer? Like how much of effort, because I think you're trying to connect a lot of things through this ontology layer, which is good to give it more context and more of a semantic context. But I guess the biggest thing that I'm weighing out is how much can you do without knowing what questions people are going to ask? You know what I mean? And so that way, trying to build that trust with, let's say, an end user who uses this agent for the first time, how can you guard against things, let's say, breaking right off the bat? And how much can you really do pre-work to instruct the agent to be able to answer, let's say, 80-20, or let's say 85-15, something like that, where you can get a good amount of success rate. Like that's my underlying question is, how much of pre-work can you do? Because I think you've done some really good stuff there, but it's hard to anticipate all possible scenarios. You know what I mean?
It's impossible to anticipate all possible scenarios, always. And with data agents, it's no different than any other application that you would build. Only when you program the agent, you use your human language instead of the programming language of any computer language, right? So, but you would need to write exactly the same. You would need to take. That's my that's my personal opinion. I'm opinionated on that because I've been in this industry for so long that I've seen it all, literally. I started with way before personal computers. I went through each and every programming language that was ever invented, mostly. Like there are some rare occasions that I wasn't interested in. But believe me, I'm not at this point, I'm not interested in learning any new programming languages, right? But approach didn't go away. You hear a lot of new jargon related to the AI. I map it in my head because there's nothing really new. Like they say a skill, I call it a function or a subroutine or whatever else, right? They say a prompt, I call it a query. And it doesn't really matter because it's the same programming concept. Now, if you say that there's a dangerous question that might be asked and you want to prevent it, right? How would you do this if you were programming your application logic, which is deterministic? You would do the if, right? Exactly the same thing. you just write an instruction. I could show you right now. It will honor it immediately. If anyone asked about this and that in such a form that has no relational information to your data source, answer that it's outside of your expertise or something like that.
I currently do that actually. Funny that you said that because I currently do that within my own data engineering workflow with Claude, obviously as a brain, and then the markdown sort of context. And I know what you're saying with respect to skills and trying to like sort of define those and so forth. I think this is just a comment, but I feel like with the new Anthropic like sort of Microsoft announcement as well, I feel like the underlying LLM that's behind Copilot per se, I think will improve. So I think this is what I think is going to happen is I think that it's going to be a little bit better in terms of not having every single sort of if statement like you're saying. But anyway, that's just my personal thought. I appreciate the time. Thank you very much for this demo. Appreciate it.
Testing is the key, as always, right? In any system. Now, you should be testing your agent exactly the same way as any other software. The major difference, of course, that the agent is non-deterministic. It's probabilistic way of executing the code. So that's why you need to have tests in your system. And you know that, for example, in Fabric, when I created an agent, what I can do with it is that I can publish it, right? So there's a publish button here. As soon as I publish button, I'll show you what's going to happen, is that in the publishing, there will be a URL, public accessible, the same as is the model context protocol. There will be a URL. It's not now because it's not published. So there is no permanent compute instance behind this agent, right? It's in the testing mode. But once that happens, you can write the code in Python or any other preferred language in Fabric, outside of Fabric, using these endpoints that will send a bunch of different questions that you know a pre-recorded answers for. That will be your test suite, and you must have it.
Mm-hmm.
You cannot do it manually.
Is that like a GraphQL sort of endpoint that you would set up and then you would basically run it against that? Or
well, you're thinking in technical terms, right? But I'm telling you that you're right. The one package that you will bring into your Python code, it's the OpenAI, because it's the OpenAI model that we're using on this conversation. That's the only one currently available in Fabric.
Oh, yeah. So
right. Yeah. So you will use that in your Python, and you will need to have a test suite that will just iterate through all the questions that you predetermined that are important. And you will get the answer from the model live, okay? And compare it with the answer that you expect. And you will decide whether the test succeeded or failed. And if it failed, you will go back to drawing board and you will start customizing, tuning up your instructions until it succeeded.
So this is like a supervised learning
Absolutely.
sort of. I mean, it basically is that. So just a question though, but like what you just said there with the panel when you open that, when you publish it publicly, that's published publicly within the tenant and the Fabric capacity, yes. Or is it? Yeah, right. It's public in that sense, not obviously public. Okay, sorry. That's what I wanted to.
No, that's the URL that requires Entra. It's behind the Entra ID sign-in. Right. So you must have a token, right? So you need to log in your code. When you execute the test suite, it has to be able to log in using, in most cases, you will just use the service principal. You won't use the individual account in such a scenario for automated testing, of course. Right.
Thank you.
You're welcome. More questions? We still have, we don't have time, but I'm available. If you want to stick longer and ask more questions, feel free.
Hi, good evening. Is it possible to share this code, like examples? Is there any GitHub URL to practice this?
Yes, but you actually don't need it because I'll show you that this is on Microsoft Learn.
Oh, okay.
Microsoft Learn ontology tutorial. It's right here.
Oh, okay. Thank
So
you.
you can just follow it to the letter, and if you have access, obviously you need to have access to Fabric, but
Yeah.
trial will work with everything except the data agent, but they have a data agent, but you would need to have the commercial capacity for that.
Sorry,
Yeah.
Alex, or
Yeah.
Alexander, sorry, one more question. Just in terms of the production, sorry, a production agent, let's say that you deploy this, it's published in a capacity. Like I'm surprised that this actually executes at the level, even speed in an F4. Like we currently have an F16 at our hospital, and it from notebook or Spark pools and the compute, it takes a lot of resources. So I'm just curious in terms of the optimization of this agent. Is it very lightweight, or does it use a lot of CUs and stuff like that within the platform, or I'm just curious with respect to just the ontology layer and the agent layer. Like, is it quite intensive or not really?
Ontology, because it's graph, it's quite intensive in the
Right, right.
compute resource when it processes complex queries, right? The more complicated your ontology model is, the more complicated questions you may expect, the more compute it will use. But
Right.
what you can do is you can separate. So essentially, the best practice is to use different capacities. So, and Fabric allows you to dedicate a capacity for AI exclusively. So for the data agent exclusively. What that means is exactly that you can limit your money drainage, right? So you don't want it to be wasted for unhelpful, wasted questions and things like that. So what you want to do is you want to dedicate a specific capacity level that you know is justified by the performance level that you tested, and leave everything else, data sources, other workloads in Fabric, to different capacities. Capacities are assigned on the workspace level. So essentially, you just
Right.
place your agent in one workspace and your data sources in another workspace, and you assign
Right.
different capacities, right?
Right. Okay. I see what you're saying. So maybe beef up whatever, like, if we need to, let's say, beef up specifically for the agent, you would maybe scale higher, or, have your data engineering workloads in a different capacity, different workspaces, and then let's say even other visual content in another type of thing. You could architect it that way too. Okay. Yeah,
Absolutely. So think
that
of
makes sense.
capacities as your virtual machines, right? So for specific workloads, you may uh, determine that it's enough to have only 2 CPUs and 8 gigs of memory, but for other workflows, you may need like 64 core CPU and gazillion amount of memory, right? So you would
Right.
definitely use different VMs for that, and VMs are your capacities. So pick and choose, right? That's how you control the infrastructure in Fabric.
Makes sense. Thank you.
Any more questions? Okay. No one said we need to stop, or not we? Everybody? Like I'm not managing that call. Okay,
Uh, uh,
Gene, if
another
we're
And
yeah,
another question, actually,
yeah,
I'm using Fabric, the trial version.
yeah,
In the admin portal now, I want to enable this ontology item, right?
yes.
So in the trial version, it does not support. Is there another way to?
No, it does. I can create ontology in a trial version as easily as not trial version. So what you do is you need to go to your portal,
Okay.
admin portal. By the way, here in the tutorial, they have in the section 0, they have specific instructions that there's the prerequisites, right? So you need to enable ontology item and create graph.
Correct.
And it's in the tenant settings right here. So if I show you how they look, that would be ontology. So I just filter by the keyword.
So this option, I'm not getting it actually. This option, I'm not getting it. The whatever you're looking, admin portal, I'm not getting.
Oh, you cannot get to admin portal because you don't have permissions. You need to ask someone who has permissions to enable it for you.
Whom should I ask?
Well, see, if you created yourself the trial capacity, you requested it and it was assigned to you, then you would see that option because you would be the admin of that capacity. But because you didn't, and this admin portal belongs to a tenant, to a specific tenant, right? So that's your login. In my case, that's my company's tenant where I have permissions to operate that. In your case, what tenant your capacity is in your fabric is deployed for, you need to find someone who can administer that with the higher permissions.
Okay, got it. Thank you.
Your IT team, most likely.
Oh, okay.
Well, keep in mind the fabric on the tenant can be completely disabled. You may not even have the fabric, so you just need to clarify that. The easiest way is just to do this using your own Microsoft account that you can acquire.
I'm getting this admin portal, but I'm getting only certain things actually. I'm not getting everything.
Yes. So you're limited. Your access is limited. You don't see everything. That's
I'm not getting it actually. What I'm getting is very limited. One actually, I'm getting capacity setting, refresh summary, help and support, and knowledge. That's what I'm getting it actually.
Yes.
If you look at the trial, I'm just getting the capacity report, notification, Power BI, data engineering works, but that's it. Other than that, I'm not getting anything.
Understood. But you're using your work email, right?
Yes, work email.
Yes, exactly. So your work email belongs to your organization tenant, which is controlled by your IT team. So if you ask them to help you with this, they will be just able to go ahead and turn that on. You don't really need to be an admin.
Okay, thank you.
More questions? No? I suppose if there is no more questions, then we can just finish at that.
Yes, if there are no other questions, I think we are good.
Right. And thank you, everyone. Really appreciate your time. Appreciate your being here and listening to what I had to tell you.
Awesome. And yeah, thank you, Alex, for this insightful session. And thank you, everyone who stayed till the very end. I know it's 7:45, but everyone stayed. Very interesting session and very collaborative as well. Perfect. Thank you so much, guys. Have a really great evening.